Hello students, in today's class we shall discuss about Dye-Azo Coupling reaction. Let's see what is Dye-Azo Coupling reaction. Aromatic diazonium salts reacts readily with phenols and aromatic tertiary amines in weakly alkaline or acidic medium to give colored substances known as azo-dyes. This reaction is known as Dye-Azo Coupling reaction. Now, let's see some examples of Dye-Azo Coupling reaction. This is the example of Dye-Azo Coupling reaction. Here we take benzene diazonium chloride. When this benzene diazonium chloride reacts with phenol in the presence of sodium hydroxide or water at 0 degree centigrade temperature, then we get para-hydroxy benzene. So these two reacts and we get para-hydroxy benzene. This has the color of orange red. So this is the example of Dye-Azo Coupling reaction. Now let's see the mechanism. In step 1, the phenol reacts with OH minus and this hydrogen is abstracted by OH minus, and as a result we get phenoxide ion. Now in step 2, what happened? This phenoxide ion reacts with this. Now this negative charge shifts from here and this double bond shifts from here to here, and this double bond attack this nitrogen, and from this triple bond a bond shifts from here to here, and as a result we get this compound. Here this bond shifts here to here, so here we get a bond, here the bond remains, and here a double bond arises. Here a double bond arises, and in this position this nitrogen is attached, and here a bond shifts from here to here, so we get double bond here, this nitrogen and this benzene ring. So students, in this carbon a hydrogen is already present, so this bond shifts from here to here. Now this double bond shifts from here to here, and this double bond shifts from here to here. Now this hydrogen now free. So this hydrogen will go here. Now what we get? Here we get a wedge. This bond gives here, this bond gives electron here. So here a double bond arises. This bond shifts from here to here. So here we get a double bond, and this double bond remains as same, and the other part will be remain same. N double bond N benzene ring. What is this? This is para-hydroxy benzene. So this is the mechanism of Dye-Azo Coupling reaction. Now if someone asks you why the coupling occurs at para position, not at the alpha position, now your answer will be that diazonium cation attacks the activated para position of the phenoxide ion to give an unstable azo-dinon, which readily tautomerizes to yield para-hydroxy benzene. To avoid steric hindrance in the alpha position, coupling occurs predominantly in the para position. So for this reason, to avoid steric hindrance in the alpha position, coupling occurs predominantly in the para position. Now let's see some important application of Dye-Azo Coupling reaction. The reaction is a good means for preparing azo-dyes. Almost 50% of the azo-dyes used nowadays have been prepared by this reaction. First, we read synthesis of congruent. So students, at first we should know that why we synthesis congruent. Now let's see we synthesis Congo red because this Congo red is used as an indicator and for dyeing cotton directly. So, for this reason, we synthesis Congo red. Now, let's see. Here we take naphthenic acid. This is the structure of naphthenic acid. And here we take tetraazotized benzidine. And this is the structure of tetraazotized benzidine. And this is naphthenic acid. Now, if these three react, then we get Congo red, and this is the structure of Congo red. Here the naphthenic acid. Now here a nitrogen is added, double bond N. Here these two benzene ring. Here a nitrogen, double bond N. Here the naphthenic acid. This is the structure of Congo red. Now let's see synthesis of Bismarck brown. Why we synthesis Bismarck brown? Because Bismarck brown is used for dyeing leather, wool and cotton. So we synthesis Bismarck brown. Now we take these three compound. Let's see the structure of compound. Here a benzene ring, in this position N2 plus Cl minus, and in this meta position N2 plus Cl minus. Now here a benzene ring, in this position NH2 is attached and here NH2 is attached, and these two are same. Now if these three react, then we get this product. What is this? This is known as Bismarck brown, and this is the structure of Bismarck brown. Now next we synthesis of methyl orange. So students, why we synthesis methyl orange? Because methyl orange is used as an indicator in acid base titration. So we synthesis methyl orange. Now here we take this compound and this compound. Now they react, and after react they produce helianthine, and this is the structure of helianthine. Now when we treated this helianthine by sodium hydroxide, what we get? We get methyl orange, and this is the structure of methyl orange. So students, I think you understand Dye-Azo coupling reaction. If you want anything to know, please mention this in the comment section.